Good morning. Today is Wednesday, September 28th.
Well, wait.
And it is an A day. All classes should.
It's designed to help you use the concept of function notation to develop your difference quotient function notation stuff. So, did it help? Did it actually make a little bit of sense? Yeah? Okay. So, where you're going to start is by substituting in numbers in for x. Oh, nice. I should have done it first, yes. Okay, so we're going to substitute numbers in for x, and then they have expressions in here that you're going to substitute in for x. This kind of helps, this part right here is helpful when you get to the difference quotient, because that's what you're substituting in. This one was a little bit bigger, a little bit more complex. When it got down to here, if this was good, because this function had two x's in here. So you substituted your -2 in there, then they threw the variable in, then they threw an expression in, two terms, and worked your way through there. Once you get down to here, you kind of could see you're actually building this difference quotient. Did anybody have any questions with this sheet? Did it flow through for you? Okay, let me move it up. Everybody got the rest of it? This is where your difference quotient starts to build. Here's your difference quotient right here. Girls, did you have the work?
Yes.
Okay. Good? Okay, take a minute to look it over. Ask me any questions, because this is really, really a good worksheet to develop this. God bless you.
How did you get the second one for 4? The 3x over 2.
3x over 2, God bless you. So you're going to plug this into the f function. My board still doesn't work. And what does this say behind it? Plus 1? Minus 1. Okay, so now 2 goes into 4 2 times. 2 times 3x is 6x minus 1. Sometimes they look weird, and yeah, they're supposed to look a little bit strange. One of my neighbors, her daughter's taking Algebra 2 at Chapel Field, and she was doing, God bless you, all these fractions, you know, when you find the common denominator with all the factors and everything, and then you cancel them all out and factor and reduce and all the other stuff. And they don't always come out to look nice. You start seeing that now, too, Chris.
Or the third one at number 5. Did you take the h out?
The third one in number 5.
Not the one for the...
This one?
Yeah.
Do you take the h out of what? This one we're looking at? Oh, can you factor it out? And that's exactly what they do. They just didn't show you this step. They factored out the h, because here's the rest of this. They plug it into this. So this is your numerator. So your numerator is 2x h plus h squared. Does that say plus? Technically over this. So they factored out the h, and then they were able to take the h out as a factor, and then they get this answer. They just didn't show you that step as they were doing it. But that is exactly the goal of your difference quotient as you get through that. We'll work a little bit more with that. This is important. Like I said, you're not going to see a practical use for it yet until we get to the end of the year and we talk limits. And that helps us as we approach a value that we cannot use. We look for a limit for that. And that's a calculus term. What you're doing is calculus work. We're still calling it by precalch names. By the end of the year, we'll kind of combine all this, and you'll see how this fits in. As long as you can follow this through. Right? Okay. some reason my board is still off. I'm gonna have someone look at it. Okay, so today, to look for this solution in. You have 3 domain restrictions. You have a fraction where the denominator cannot be 0. You have a radical where if it's an even index, under the radical cannot be negative. And you have a radical in a denominator, which in addition to not being negative, it cannot be 0. So take a look at a couple of these examples. Does this have a domain restriction? What's this going to give us? If I graph this. Parabola. Which way is it going to open? Up. So we've got a parabola. We graph it. It opens up. It opens up starting from -4 down here somewhere. And it opens up. We look in our table and it has no errors in there. Every x we're allowed to use. I don't know why my board is so off. Usually it's the edges. Today it's the inside. So we have a parabola opens up. If we graph this, we have no errors. Every x will find a y. So my domain is all real numbers. Any infinities get soft brackets. Soft brackets because they go on and on. This one, the second one, has a denominator. The only thing I know about a denominator is it cannot be equal to 0. So therefore, I want to find the values of x that make this 0. Some of you are getting a little confused when to set it to 0, when to say greater than or equal to 0. Your denominator, just start like this. Whatever this is, if it's 0, I'm in trouble. So set it equal to 0. In this case, either give me your perfect squares. I don't care which way you factor. If you do it this way, don't forget you get a plus and a minus 2. Now, those are the values that we cannot use in here. If I use those, they give me a 0. So I take this out of my all real numbers. I take it out because that's what we start with. And I give you, for a domain, what is left when I remove those. Read left to right. You're coming from negative infinity. You're stopping at -2. It's a soft bracket because I can't use -2. I can use -2.0000001, but I can't use -2. I jump over it. I can use -1.99999. So I start up again at the other side of it, and I have to include this part. So I go from here to 2. If you say jump over it, it's the easiest way to remember it. Jump over 2, and then keep on going to infinity. There's no hard brackets on the ones that you cannot use. Good? And the last one that's here. What's my domain restriction here? What does this radical mean to me? Can't be negative under my radical. So therefore, if it can't be negative, I can't use any of these. I can't use when it's less than, anything less than 0. So I say the only thing I'm allowed to use is this part over here. And in this case, yes, the 0. So I'm going to set this equal to, or just set up my inequality, so that I'm greater than or equal to 0. And I include the 0 because I'm allowed to have a 0 under a radical sign. Any even number, 4 squared, any even number is going to operate the same way. So I notice this has an inequality. So I follow my rules of inequalities, of quadratic inequalities. I find the roots first. I set this equal to 0. I find my roots. Should these be open circles or closed circles? Closed. because I'm allowed to use a 2 and a negative 2. If I put a 2 in here, 2 squared is 4, I'm allowed to get a 0. Which way is this parabola opening? Up or down? Down. And if you don't catch that right away, put it in your y1 and graph this. And again, test your intervals. Look to the left of negative 2, see the value of y. Look in between, look to the right. Your parabola is going to go like this. So I want wherever this is positive, I don't want these negatives. So wherever it drops down in here, I don't want this, I don't want this. I just want these. So my domain says, and I can use negative 2. My domain says negative 2 to positive 2. And I'm not really getting that, so I'm going to test it. I'm going to test, God bless you. Let me test a 0. If I put a 0 in here, 4 minus 0 is 4. I can take the square root of 4. If I put a 3 in here, 3 squared is 9. 4 minus 9, well, there's my negative 5, and that's outside of my domain, right? So whether you test it, put it in your y1, put this guy in your y1, test to the left. You're just looking for the value of y, the positive or negative. This has a negative, this has a positive, this has a negative. This is, unfortunately, we had to do this because this was a quadratic inequality. And this is my domain. Just this guy. Questions? If I do this, what's going to be my domain now? Soft bracket. Good. It's the same exact domain, same parabola. The only thing is, these will be open circles. So now I have a soft bracket. I can't use negative 2 or positive 2. Do you want your shot?
Yes.
Oh, good.
This would be in another office.
Well,
I need
you
extra.
didn't have an assigned stuff. Somebody was just covering every period. So, yeah. Put your stuff is here so they
Thank
look
you.
fine.
Thanks
No
so much.
problem.
Sorry, Bob.
No problem. So this was a soft bracket because we cannot use a 0 in the denominator. Good? Okay. These domains are going to start clicking. Some of you, they're clicking with already. Some are still saying, I don't get the difference between a domain and a solution. Domain is what we look at first. Domain is what we say, what numbers am I allowed to look at to find my solution? The domain restrictions will help you because sometimes when you find a solution, if you're not allowed to use a negative 2, it's not going to work. So it kind of tells you ahead of time. Piecewise. A piecewise function will fall over a restricted domain, or usually a whole domain, and use parts of it. Now, for us to do our piecewise function, if you're struggling with the piecewise, use a number line. Let me put it in time for this. I'm going to number these. This is my 1, 2, 3. It's as if you had 3 equations here. Y equals 4. Y equals 4 minus negative x squared. We just graphed that guy, right? Y equals 2x minus 6. I have 3 sets of equations here. However, they're only allowed to use a part of my domain. So I'm going to start my domain line. I notice 0. So my first one says from 0 to here, my first one is allowed to use. My second one says from 0, but I can't use 0, open circle, to 2. And I can use 2. This is my second one. My third one says from 2 to infinity is my third one. So essentially I'm using my entire set of real numbers to graph this. An easy way to do this is look at your domains. If you struggle with this, separate your domain and then say, okay, I'll take the first one. I'll use that. Here's my first equation. Make an XY table. I'm using all these negative numbers up to 0. So I'm just going to say -3, -2, -1, 0. One of the things in precalc that is tough to get used to, we don't really work off of a grid. We kind of just work off of just a ghost of an axis there. And we don't plot specific points, we kind of sketch everything. And it takes a little while to get used to the sketching part, because we don't really give it like a true point. In Algebra 2, you had to do completely the opposite. You had to give points, and if you didn't give those points on the regions, you didn't get credit for it. In Precalc, we do it a little different. You're going to see we sketch a lot. So I'm going to put this in my calculator, whatever this equation happens to be, and just look at my table for these 4 values. In this case, everything is equal to 4. Let me grab your sheet for today.
Is the homework now or?
No, okay, that's good.
All right.
You're good. All right, so this is my table for that one. Good? All right, the second one. The second one says I can use from 0, okay, and this 0, put a little closed dot, because that 0 we're going to count. The second one says from 0 to 2. I can even see on my number line, I can only go from 0 to 2. My 0 is open, put an open circle, and my 2 is closed. Now, put this in your Y1, and just give me these values from your table. If I put a 0 in here, I get a 4. If I put a 1 in there, I get a 3. If I put a 2 in there, I get a 0. Good so far? Okay. And the third one, you're allowed to use from 2 to infinity. So 2, 3, 4. These are fine. 2, 3, 4. This is a line, so this is fine. And this guy is open. The reason this is a function is because where one is closed, the other one is open. This one's closed, this one's open. So when you try a vertical line test, they will be where you wanted them to be. They will be a function. So here's the fun part. We're going to graph this and sketch at the same time. We're really, like, you can put your points there, but we really don't make like all these little tick marks like this. If you need to in the beginning, do it, but eventually you'll be able to eyeball this. So -3 says, okay, I have a 4. -2 says I have a 4. -1 says I have a 4. 0 says I have a 4, and that's a closed dot. This guy is going this way. Okay. It's a horizontal line. Y is equal to 4. But the only part, if Y is equal to 4, it goes all the way across. But the only part I wanted was when it's 0 and the negative numbers. Do you have to do these tables? No, but it's good if you're trying to get the concept. The second part, I label this. I say 0, 4. This is open. I met it right there. I have 1, 3. I have 2, 0. And this is closed. This is a parabola. So, and it's opening down. So this part has a little bit of a curve to it. It's not a straight line. Then my last one, we didn't put points in. Plug a 2 in here. So this is 4, this is -2. Plug a 3, this is 0. Plug a 4, this is 2. So start here at the 2, I am a -2. It's open. At the 3, I'm a 0. At the 4, I'm a 2. And it's a line that goes like this. It would come this way. It would cross the y-axis at -6. But I don't want any of that part. I want from here on out. It's a function because if I drop a vertical line, it passes my vertical line test. And again, I didn't have to put any tick marks. I just kind of figured out where they were going, and I put them in there. We do a lot with sketching. We do a lot with transformations. So when we do this, like for this instance, for this one, we'll turn this around and you did a lot of transformations last year. So you'll start your X, you'll go up 4, it'll turn down, we'll sketch. We'll mostly just sketch everything. We'll be doing this, sketching. We very rarely put the points on here. If you have to put the points on, and usually my pre-cal kids, when they first come in, they tend to put the little tick marks. If you need to do that, go ahead and do it. As you get more comfortable, you'll do it without the tick marks. We do a lot of sketching. It is like the complete opposite of Algebra 2. Algebra 2 says, I want to see all your points. Another thing we do in pre-calc that's nice is you do not have to rationalize your radicals in the denominator. You know how you have to say 1 over radical 3 times radical 3, and get rid of the denominator? We don't do that in pre-calc. We leave the denominator the way it is, with a radical. So good so far? Questions? Okay. Check that. All right, so let's try one more. Okay, let's work your number line, and then I'm going to have you come up with a table of values. So again, 1, 2, 3. This one uses from -2, and it's open all the way out here. That's my first one. My second one, same one as we had the last time, uses from -2, closed, to +2, open. And my third one uses from +2, closed, and on. That's my third one. So try to set the tables up. Take a second and set the tables up. Give me a 1, 2, and 3. Remember, these do not have to connect when you do them. They can be like the other one and had a little jump in between there. And we're going to look at those things later. We're going to call some continuity, some discontinuity. We get to call those by different terms, and those are your calculus terms. Okay, so what kind of numbers can I use for the first one? Look at this table. So, Chris, what do you have for your first one? What kind of numbers do you have here in your X's?
-5, -4, -3, -2.
Okay, and a -2. And you can't go any further than -2 because that's where they stop. And this one is open. So what are your values in here for Y? Okay, very good. Second graph. What numbers can I use in my second graph? Julia.
-2, -1, 0, 1, 2.
Good. Because that's all they give me to use. It is closed at my negative 2 and opened at my positive 2. And Imani, what can I use in my third one?
2, 3, 4.
Okay, 2, 3, 4, and I am closed at my 2. So Julia, what were your y's for these values?
I found -2 is at
0. So the 2 would also be a 0, right? And the 0 in the middle would be a 4. So 4 minus 1 is 3. You could just say radical 3.
Wouldn't the 0 be a 2?
The 0 will be a 2. Thank you. And this will be a radical 3. And we can leave the radical 3. Okay. And the last one, Imani, what did you get for your... We squared your negatives. Is that what you're asking me? We squared these guys?
No, what did you for -1
A negative 1 would give me a radical 3. So when we graph these, start with the first piece and look where you're ending to. You have a -5, +3, a -4, 2, a -3, 1, a -2, 0. This might be an easy spot to start if we're just sketching this. So -2, 0 will be here, and it's a line. It's going like this. It's a negative slope line. Slope is 1. If you want to put your points as you go, fine. If you can catch the sketch, work on the sketch. The middle part, the highest it's going is 2. So we started here, and now I'm going to close it here, and we're coming around to this guy where it's opened at 2, and it's just making a little arc. It's like half of a circle. Then the third one comes through. It closes at 2, 5. 2, 5. And it's also a line that has a slope of 1. So somewhere it looks like that. We're sketching. So if you can kind of eyeball the points, try it. If you need to plot them, plot them. You'll get the catch of the sketch. Gabby, did you have a question? If it's a radical, it can't have any negatives in here. So, say that again. I can use a negative number because this is where my domain is. Remember, we looked at this domain in the example. So we said we took this and we said 4 minus x squared had to be greater than or equal to 0.
Yeah, I messed it up. I was thinking it had to be a V shape but that's actually not.
That's it, yeah. And sometimes my graphs it's not always rounded or pretty either, so, yeah. But the concept here is if you drop a vertical line test, one's open, one's closed. One's open, one's closed. So I still have a function. Hence we call this a piecewise function. It's just a function all pieced together from different things. And they don't all have to meet. I don't have to have something that meets here and comes out in a different direction. It can go wherever as long as it passes a vertical line test. Okay? And at the same time, try to get